In this video, we'll discuss some textbook questions of class 12 Cbse Ncert book. Always children feel very difficult to write the answers of questions related to relation and function. So I thought to write some sample answers for them, and I'm starting from exercise 1.2 textbook, but first I'm taking the question number 2 because this is the most fundamental question which will help you to do other questions of this exercise. So let us proceed. It has many parts. First part is check the injectivity and surjectivity of the following functions. And if you have seen the previous videos, you must have learnt what is injectivity. It is one function. To prove one, we take that if fx1 is equal to fx2, then implies that x1 is equal to x2, then it is injective function. And for subjectivity, we test that whether it is 1 onto or not onto. For onto, we have to see that for every y belongs to the codomain, there must be x in the domain. So based on this, the whole question is framed. The first part of the question is f is defined from natural number to natural number given that f of x is equal to x square. So we have to first check whether it is 1. So our solution starts f defined from n to n given by fx equal to x square. So in question, first you will mention what is the function. Here we will write that for x, y belongs to natural number, f of x is equal to f of y. Let f of x is equal to f of y. This implies that x square is equal to y square, putting in the function. So this implies that x is equal to y. It's not that x is equal to plus and minus both the y, because we have taken only the function is defined from only natural number to natural number, which is always positive. So x is equal to y. So we took fx is equal to fy and we reached at x is equal to y. This implies that it is one function or it is injective function. So part 1 is completed. Then coming to surjectivity. So we have to think of a number here which has no pre-image in natural number, or we have to find some natural number in the codomain so that function cannot be defined for x whose result is that y. We have taken the y is 2. Y belongs to n codomain, and you will find that there does not exist an x in domain such that f of x is equal to x square and which is equal to 2. So there is no number in natural number set so that its square is equal to 2, or we can say 2 has no pre-image in domain. So is not surjective. So the function is injective but not surjective. Next, coming to second part of the question. Check the injectivity and surjectivity of the following functions. Here function is defined from integer to integer given by fx is equal to x square of x. So here domain is also integer and range is also, codomain is also integer. So solution starts. The function It is defined from z to z given by fx is equal to x square. So here uh, we'll take first, let f of x1 is equal to f of x2, and we have to think of such x so that its square is equal. Now we know that f of minus 1 if we take is equal to minus 1 square is 1, and f of 1 is also 1 square 1. So f of minus 1 is same as f of 1. So fx1 is equal to fx2, but we are not getting that x1 is equal to x2 because minus 1 is not equal to 1. Then is it injective? No, it is not injective. Next, for surjectivity. Here also think some non-example where the function does not satisfy. So minus 2 belongs to the codomain z integer. There does not exist any element x belongs to the that f of x equal to minus 2 or x square is equal to minus 2. So there is no such x whose square is equal to minus 2. Is not surjective. Is neither injective nor subjective. Next is third part. Here same you have to check the injectivity and surjectivity. Function defined from real number to real number given by fx is equal to x square. So same question you must notice that it is asked for function defined from natural number to natural number. It is for asked from integer to integer, and it is asked for real number to real number. So answer is not always same. You have to see how it is different. So solution. We define the function first. Next, we'll let some function for both the. The same example we can take as we did in previously. F of minus 1 is same as f of 1 because minus 1 whole square is 1, 1 whole square is 1. But 1 is not plus 1. So the is not injective. For subjective, again you can take the example of minus 2. It is a very good tool for solving these questions. So minus 2 belongs to R codomain. There does not exist any element x belongs to the domain that function f of x is minus 2 or y can be minus 2 because x square cannot be minus 2. There is no such x for which x square is minus 2. So the function is not surjective. So the function f is neither injective nor surjective. Now coming to fourth part. Same question. Now function is defined from natural number to natural number given that f of x is equal to x cube. So first define the function. What now xy belongs to n, f of x is equal to f of y. So x cube is equal to y cube. Now this implies that again x is equal to y because both are natural number. So f is injective. Take the example 2 here. There does not exist any element x belongs to n such that f of x is equal to 2 or x cube is never be 2. So 2 has no preimage, then is not surjective. Now coming to last part of this question, check the injectivity and surjectivity of function. F is defined from z to z, integer to integer, given by f of x equal to x's cube. Now I hope you can try for it. You pause the video, try to do yourself. If you are not unable, then I think you can take the help of this. Define the function first. Then for xy belongs to z, let f of x is equal to f of y. So x's cube is equal to y cube. Then implies that x is equal to y, because though the domain and the codomain are integer, they contain negative, but when x's cube is equal to y cube, x is only y, because 1 cube is 1, but cube of minus 1 is minus 1. So it is injective. Take the help of 2. 2 cannot be a cube, so 2 has, so there does not exist any element x belongs to z such that f of x is 2 or x's cube is 2. F is not surjective. So is neither injective, the function is injective but not surjective. So this is exercise 1.2. Let us start from question number 1. Show that the function f is defined from non-zero real number to non-zero real number defined by f of x is equal to 1 by x is 1 and on 2, where R star is the set of all non-zero real numbers. Now second part is the result true if the domain R star is replaced by n with codomain being the same as your non-zero real number. So what is the function? Function is defined by fx is equal to 1 upon. So first part is for on 1 1. So what we have to show? We have to show that if fx is equal to fy, then we will reach in the conclusion that x is equal to y. Then we can prove that it is 1 1. So please note that how to write the answer. Suppose x comma y both belongs to non-zero real number such that f of x is equal to f of y. So this implies that 1 upon x is equal to 1 upon y. What does it implies now? It implies x is equal to y. So proves that f is 1 1. Next is for on 2. When fx is equal to 1 by x, this implies that y is equal to 1 by x or x is equal to 1 by y. So for y belongs to real number, there always exists x is equal to 1 by y, because y is not equal to 0 here. So now putting in place of x in f of x, we'll get this is y by 1 by y. In place of x we put 1 by y, so this is equal to same as y. So when you are getting f of x is equal to y, so it is a function. So f is on 2, f is 1, function is 1 1 and on 2 when it is defined from non-zero real number to non-zero real number. Now let us come to second part. Here now domain is replaced by natural number. So g is defined from natural number to non-zero real number, and g of x is equal to 1 by x. So again testing for 1 1. For 1 1 we'll go for the same. X belongs to n, y belongs to r. F of x is equal to f of y. Or 1 by x is equal to 1 by y. This implies x is equal to y. So also 1 1. Now for on. Now again, as done previously, we have to think of a number which belongs to codomain which has no preimage in domain. So let us take 1.2 or any rational part 1.3, anything. It is clear that G is not onto as for 1.2 belongs to R because there does not exist any x for which g of x is equal to 1.2. That means 1 upon any natural number cannot be equal to 1.2. So the function g is 1 1 but not onto. So result is same when domain is changed to non-zero number to natural number. So it is 1 1 but the result is not same because it is the function is not on 2. So next is question number 3. Prove that the greatest integer function f r to r given by f of x is equal to greatest integer function is neither 1 1 nor onto, where square bracket x denotes the greatest integer function less than or equal to x. That means if 1.2 will put in the greatest integer function, it will give you 1 only. It will give you the integer less than the value. Okay. So now coming to solution. So first we'll define the function fr to r given by fx is equal to box x. So here I am taking two examples. When we put in function, it gives the same value. One is 1.2, one is 1.9. So if we put 1.2 in the greatest integer function, the output will be just 1. Similarly, if we put 1.9 in the greatest integer function, it will be 1. So there are two x for which I am getting the same y. So f of 1.2 is same as f of 1.9, but 1.2 is not equal to 1.9. So what about f is not 1 1. Now for onto, we have to think of such y in the codomain which has no preimage in the domain. And for this function, the range is only minus all integers 0 1 2 3 so on. So we have to think of which cannot be a range. So let us a decimal, because this decimal cannot be in the range, it will be only integers. So we will show that this 0.8 will not be in the range, or it has no preimage. So it is known for fx is equal to greatest integer function, it is always an integer. Thus there does not exist any element x belongs to R such that f of x is 0.8. So f is not onto. Hence the greatest integer function is neither 1 1 nor 1 onto. So this is exercise 1.2, question number 4. Show that the modulus function f defined from R to R is given by f of x is equal to modulus x is neither 1 1 nor onto, where the definition of the function is modulus function is equal to same as x if x is positive, it is 0 when x is equal to 0, and f of if modulus is x is negative x when x is negative. So how to get the solution? So for 1 function, we know that the condition is if fx1 is equal to fx2 and implies that x1 is equal to x2, then it will be a 1 function. So we'll take 2x where f of x will be the same. So this function in the answer also. Now it is clear that f of minus 1 is modulus of minus 1 is equal to 1. F of 1 is also modulus of 1, this is equal to 1. So we are getting two set of x for which f of x is equal to 1. So f of minus 1 is same as f of 1, but minus 1 is not equal to 1. So this is not 1, 1. Now we will go for onto. We have to think of some number in codomain which has no pre-image in the domain, or we have to think of a x belongs to the domain for which f of x is not equal to number which is present in the codomain. So let us take an example. I am consider minus 1. Minus 1 is belongs to real number. Cannot get modulus of any number which is minus 1, because we know that f of x is modulus x is always non-negative or positive. There does not exist any element in x in domain R such that f of x is equal to modulus x which is equal to minus 1. F is not onto, function is neither 1 nor onto. So this is exercise 1.2, question number 5, and the question is about signum function. You have to prove that it is neither 1 nor 1 on 2. So signum function is defined in this way. It is defined from R to R, and the value of fx is equal to 1 when x is greater than 0. It is 0 when x is equal to 0, and it is minus 1 when x is less than 0. So let us proceed. Let us find the solution. So the solution will be the same way. First we will prove that it is neither 1, then we will prove that it is not onto. When the question is prove that it is neither 1 nor onto, then the difficulty level of question decreases 50%. It becomes easy because you know where to reach. So first we will define the function, we will write the answer. Then again you have to find out 2x for which you will get same f of x. Then it will be 1, not a 1, it will be many 1. So this definition is when x is greater than 0, its y is always 1. So f of 1 is also 1, f of 2 is also 1, but 1 is not equal to 2. That means we wrote the condition that f of x1 is equal to f of x2, but x1 is not equal to x2. So it is not 1. Next, for onto, we have to think of any number which is in the codomain which has no pre-image in domain. or we have to think of any number for which the function cannot be defined for x belongs to the domain. So here f of x has only 3 values. That means its range is only 1, 0, -1. But what is the codomain? Codomain is whole real number. So when range is subset of codomain, it is a into function. We'll write that an example I have taken -2. In codomain R, there does not exist any x in the domain such that f of x is -2. So f is not onto. So sigma is neither 1, 1 nor onto. I hope you learned how to write answers for questions based on functions. Try some questions yourself. Self-learning is the best learning. The session will be continued. Do not worry about difficulties in mathematics. I can assure you mine are still greater. It was quote of Albert Einstein. So subscribe my channel. Stay safe. Learning cannot be stopped if you are determined to learn. Thank you for watching.